So a couple of application problems of the Pythagorean theorem here. What happens is there are plenty of situations in which we construct right triangles, sometimes without even realizing it, but then we can use the Pythagorean theorem to find missing pieces or find lengths of those right triangles. For example, here I have a 12-foot ladder that's placed against the side of a house. The base of the ladder is 5 feet from the house. I want to know how high up I'm going to be able to reach if I place the ladder like this. So once again, so here's the house. I've got my roof on here, all right? And I'm leaning the ladder up against the house. So here's the ladder being leaned up against the house. And that's a 12-foot ladder. So that measurement is 12 feet. That's the length of the actual ladder. And then it says the bottom of the ladder, the base of the ladder, is placed 5 feet from the house. So right here, this is a distance of 5 feet. And so what we've done is we've created a right triangle. And if I want to find out how high up I'm going to be able to reach, well, that's how high up the house this thing is going to be. That's this measurement right here, okay? And that's the piece of the right triangle that I want to find this time, okay? So I'm going to call that B because it looks like the longer side of my right triangle. And now I use my Pythagorean theorem. And once again, when you do the Pythagorean theorem here, I'm going to do 5 squared plus B squared equals C squared. Remember, C is the hypotenuse, okay? And the hypotenuse is represented by the ladder this time, so that's why the 12 goes by itself. Leg squared plus leg squared equals hypotenuse squared. I simplify. And now remember, using my algebra skills to solve this, I have to subtract the 25 from each side. And now to get rid of a square, I square root. Okay, so I take the square root in order to find the value here. And this is a job for my calculator. I punch it into my calculator. It looks like I get a 10.9 when I punch that in. Okay, so again, that's 10.9 feet. And that's just telling me how high up I'm going to be able to reach when I lean this 12-foot ladder up against the wall. Okay? If I look at this one, it's another ladder example, but kind of making it just a little bit more difficult and a little bit more applicable here. The peak of a roof is 27 feet high. See, this time I want to figure out what size ladder I'm going to need. So the peak of the roof is 25 feet high. As a safety rule, the base of the ladder should be placed at a distance that is approximately 1/4 the height that you're trying to reach. And so we want to know what size ladder I'm going to need. So once again, if this is my building here, okay, and the roof kind of goes this way. It's a really great three-dimensional drawing that I've drawn, okay? But I'm trying to reach the top of this thing, so I'm going to lean my ladder like this so that it reaches the top. And really, the distance right here, the height to the peak, this is the 27 feet this time. And the question is, what size ladder do I need? They also give me some information about what this distance down here should be. It says I should place the ladder, the base of the ladder, 1/4 of whatever the height happens to be, okay? So that's a general safety rule that'll keep the ladder from sliding out from under us and keep it pretty stable. So to find that distance down there, I'm just going to say, hey, let's take this 27 times 1/4. And really, that's the same thing as dividing by 4. It gives me a 6.75. That's how far away the base of the ladder should be as a kind of a safety precaution. See, if it's too close, then I have too steep of a climb, and what happens is I climb up, it'll make the ladder tip over backwards. But if it's too far away, it might make the bottom end slide out, and then the ladder falls down. And so as I look at this thing, I want to find the length of the ladder, which is the hypotenuse this time. So I'm going to call it C, and now I do my Pythagorean theorem. So let's see, A squared plus B squared equals C squared. And once again, this is a job for my calculator, so I'm going to simplify these pieces. When I square this guy, it gives me 45.5625, which is kind of ugly, but that's what it is. Here, that's a 729. And now when I add those together, I get a 774.5625. And again, to solve when I have something squared is I take the square root. So I take the square root of this thing. And so what it tells me is the length of my ladder when I take the square root. Let me do that on the calculator. Needs to be about 27.83 feet. Okay, and so if we're kind of rounding up, what I really need is a 28-foot ladder for this thing, okay, in order to do this safely.